Okay, so there is a condition that must exist in order for you to be able to multiply two matrices. Remember, to add and subtract them, they had to be the same size. They do not have to be the same size in order to multiply. But what has to be true, what has to be true is that when you compare the size of the first matrix and this one, let's go ahead and write this matrix right here, is a 3 by 2 because it has 3 rows, row 1, row 2, row 3, right here, these 3 rows, and these 2 columns, column 1, column 2. So it's a 3 by 2. This thing right here, matrix B, is a row 1, row 2. So it's 2 by 1 column. It's a 2 by 1. Now this matrix pair right here, these two matrices will be able to be multiplied because these two numbers right here are the same number. So in other words, the rule or the condition matrix for you to be able to find a product, the condition is that for matrix 1, for one matrix, okay, for this matrix, being multiplied by another matrix, the number of rows, I'm sorry, you've got, this is going to have a number of rows times a number of columns. This one will also be rows and columns, but this number right here must be the same number. Okay, so in other words, the number of columns in this matrix must match the number of rows in this one. So this matrix had 2 columns, this one had 2 rows, the numbers match, so we are able to multiply. So in other words, a 5 by 3 can be multiplied by a 3 by 2 because the 3's match. 3 by 1 can be multiplied by a 1 by 4 because the ones match. A 2 by 2 can be multiplied by a 2 by 4 because these 2's match. Okay, so if you multiply a 2 by 3 times a 2 by 3, you can't multiply because these two numbers right here do not match. The number of columns in this much match the number of rows in the second one. They don't match, so you can't multiply. So not only are these numbers the size of the matrices important to determine whether or not you can multiply, but they also determine the size of the product matrix. So in other words, if this is matrix A and this is matrix B, then matrix AB, the product of those two, is going to be a 5 by 2. And the reason it's a 5 by 2 is because it's going to be the number of rows in this matrix the answer matrix is going to have the number of rows of this one and the number of columns of this one. So the AB matrix is going to be a 5 by 2. So if this is, let's say, CD and this is matrix EF, then matrix CD, the product of those two, this one right here is going to be what size? It's going to be a 3 by 4. And the matrix EF, the E times F matrix, or the product matrix of E times F, is going to be what size? A 2 by 4. So the size of the matrix in multiplication is a little bit different for addition and subtraction. Addition and subtraction, they had to be the same size, and the answer was the same size. But for multiplication, you've got a whole lot of other things going on. Now, what is actually done by hand is interesting. So I'm going to take this matrix A that we have right here, And remember, we said that we are able to multiply these two. Oh, my writing is really sloppy. And B is a 4, -2. Okay, so we said this one right here is 3 rows by 2 columns. This is 2 rows by 1 column. So we know that we can multiply because these two match. Okay, so they're the same. So I don't know, you can circle them, they must be the same, or whatever, method you want to use for checking these must be the same. The AB matrix will be what size? It'll be a 3 by 1. Is a 3 by 1. So I'm going to draw the 3. Remember, this means it's going to have 3 rows. So there's the 3 rows, and it's only going to have 1 column. Okay, so this is going to be, so my answer is just going to be 3 numbers. It's going to be 3 rows and 1 column. Now, the answer, the number that we get when we multiply, now, as I show you this, I don't want you to get overwhelmed because you can always use a calculator. But when you multiply by hand, you simply take everything that's in row 1 right here, and you multiply it by everything that's in column 1 over here. So we're going to multiply, and I know that this is row 1, column 1, so that's how I know what to multiply. Multiply the numbers in row 1 times the numbers in column 1. So I'm going to multiply 2 times 4. I'm going to say 2 times 4, and then I'm going to add that to 8 times -2. 8 times -2. So 2 times 4 plus 8 times -2. And that is going to give me 2 times 4 is 8, and then that's 8, and then that's -16. Put an 8 together with a -16, and I get a -8. So that's going to be the number that's in that first spot in row 1, column 1. Now, this spot right here, this is row 2, column 1. Okay, so since that's row 2, column 1, I'm now going to multiply the numbers in row 2 times the numbers that are in column 1. So I'm going to say -7 times 4 plus 5 times -2. So -7 times 4 is -28. So that'll be a -28. And then 5 times -2 is -10. So this is going to be -38. Because a -28 and a -10 make -38. And then this last row right here, what's the address of it? It's row 3, column 1. So that tells us that to get this number, we multiply row 3 right here. Row 3 times column 1. So 1 times 4. 1 times 4 plus 3 times -2. Okay, and 1 times 4 is 4. And then 3 times -2 is -6. Put 4 and -6 together and you get -2. So I'm going to go ahead and stop this video, but we'll start the next video by taking these two matrices and multiplying them on the calculator to see if we got it right.